Hello, how are you doing today? Welcome to this exciting and interesting new class. This time we are going to thoroughly and in-depth explore the issue of security because, well, the next topic in the curriculum is exposing the application on a URL that could be in a public DPS, let's say, in a cloud instance, or on a Linux server exposed to the internet. And therefore we must certainly, absolutely, essentially take certain absolutely essential precautions. First of all, we have to consider that OMniLeads will interact with three external agents, in particular, let's say three different types of sources, specifically various sources that will be responsible for sending requests to the SPIP stack of OMniLeads of the instance. These will be the voice IP SIP world, which is essentially the point at which Asterisk, a powerful open source software, interacts and integrates with the traditional telephone network, the expansive world of web users, and the innovative technology of WebRTC. When I say web, I am including WebRTC, that is, the flow of audio and/or video between a browser and OMNIDIT. And the observability or monitoring stack, which is also known as centralized monitoring, will mainly send a hypertext transfer protocol, HTTP, request to port 9090, where Prometheus is located. The monitoring team here collects the application's performance metrics and usage statistics to respond to requests coming from the stack. Therefore, it is strongly suggested and highly recommended that we proceed to open the SIP part in the cloud firewall. This should be done carefully and meticulously, ensuring that it is based specifically on the source IP address of the incoming requests to maintain security and proper functionality. That is, we are going to make accessible ports 50, 60, and from port number 40000 up to port number 50000 UDP, as long as the request, let's say for example, comes in this case an RTP audio packet from the endpoint with which I trunk at a SIP level. Here it is a SIP provider or some soft switch such as Asterisk or whatever system makes a trunk connection with OMniLeads. It sends calls out and most importantly sends us new requests, which we will enable here. That's why here it is mentioned if testing can involve more than one IP, right? That we allow approximately 50 to 60, for example. Regarding the web part for users, well, let's say opening it to the internet, if there are possibilities here to filter by geographic zones, you can fine-tune it better. This will help make the web part more efficient and useful. But, well, assuming that this instance needs to be accessed and utilized from various different and multiple IP addresses because it is a contact center that works with remote or distant home office agents, well, in this case, and well, for what we mentioned about the observability stack, simply declaring this will generally be an IP address, which is where the centralized, continuous, and ongoing monitoring and tracking of all deployed OMniLeads instances is hosted. Well, this will also have a clear source IP, and it is through this, well, that we will allow access to OMniLeads. Request destined for port 9090 where Prometheus operates. With this in mind, we can quickly exemplify here with one of these cloud firewalls, which are all very similar in design and very intuitive to use. They offer robust security features and are user-friendly, ensuring easy configuration and management. One directly says, well, I want to allow HTTP, as we said, HTTPS, which is the web part, to everyone within what is basically TCP, essentially. Within TCP, well, SSH here, each person can basically work on it and fine-tune it and improve it. Back to the pencil, these would be the requests that reach the administrators of OMniLeads. We mentioned the web part, and here we have it. And we also mentioned the part of a high port, which is actually indeed 9090. To clarify, my monitoring system, designed for accuracy, operates at this specific IP address, ensuring that all monitoring. So I filter it there by applying specific rules and conditions. Here I leave a lock mechanism that only opens when requests come from this specific IP address, which is where my monitoring center is located, to port 9090. This ensures that only authorized access is granted. We continue here with a detailed analysis of the TCP graph. which is crucial for understanding network performance. And of course, later on, we start adding some VP rules to enhance the overall efficiency and reliability of the system. On one hand, we mentioned the numbers 50 and 60, which are significant because they represent an IP address that must be provided by my internet service provider. This IP address is crucial for establishing a connection through my SIP trunk. To elaborate further, the SIP trunk is a method of sending voice and other unified communication services over the internet. The IP address acts as a unique identifier. RTP, which stands for Real-Time Transport Protocol, can be used for a range starting from 40000 to 50000. This protocol is crucial in network applications such as video, We will also assume that this information comes from the carrier provider, which is the company supplying us with the SIP trunk for outbound PSTN calls. This provider ensures our communication infrastructure is reliable and efficient, allowing us to make. And then we have the WebRTC part, which is a crucial component in real-time communication, the audio data that will seamlessly flow between OMniLeads and the web font of the people with whom the agent makes phone calls. In this process, the data transfer rate is approximately between 20000 to 30000. This is SRTP encrypted RTP between the browser and the RTP engine. It is a securely and safely encrypted connection because it goes out to the internet. This scenario is considered the most liberal of all possible scenarios, taking into account various factors and perspectives. So now we have talked about 443, 20030, 1000 for everyone, 5060 for the chip provider, for when the simulator ends, for the C provider, 9090 for the monitoring stack. These are the specific inbound rules and regulations that my cloud firewall will be applying, providing comprehensive management and control over incoming network traffic.